Guys and girls, it's Noah time! Noah time!
Alright, so your lesson today is about continuous functions. Continuous functions. Now, again, this goes back to a bit of English. Functions. The word here is really continuous. English, most of you are in English 12 by now. You should know the meaning of continuous. Samandeep, what does continuous mean? Keeps on going. And in grade, you've probably seen this little trick before. Your friends play this little game with you. See, continuous means keep going. In grade 7, you had something like this picture. And your friend asked you to draw this picture without lifting up your pen. That's called drawing a continuous graph. How many can draw it without lifting up your pen? The moment you lift up your pen, you just broke the continuity. It's now discontinuous. So this little puzzle that you were given before was actually a calculus question. Try it. And when I walked around, most of you could. How many could actually draw it without lifting your pen? Hands up. 1, 2, 3. I would say around 20% if you can. So continuous means one smooth motion without lifting up your pen. Without lifting up your pen. Hi. Sure I can. If I give you, but the question is, if that was it, calculus would be too easy. Every grade 8 student can do that. So there has to be a bit more to this continuous function. But in calculus, we don't deal with envelope shapes. We deal with nice parabolas. If I draw this right here, is this continuous? Continuous. Is it simple yes or no? Karanveer, yes or no? Yes, because you can draw that without lifting your pen. Easy. Because why? Every point is there. I can draw that with the lift of my pen. What about this one? This is a parabola with a gap missing. So the answer for here, this is easy. That's yes. Because why? Every point is there. But what about this one? Karanveer, what was it? You technically can, but there's a gap here. So let's say a gap. Can you draw this without lifting your pen for a gap? No. Well, you can retrace it, but to pretend it's not. No, you can't. Even with the circle. If there's an actual gap, then you can't. So the answer is no for this one. Because why? There's a gap here. Gap. Okay. Which means I can't do this. Easy stuff. But what if I give you this one? So I'm saying, Miss Note, the reason why you can't do that is there's a gap. It's true there's a gap. What if I fill in this gap right here? And I say that point is actually down here. Okay. Who have Karn? Continuous or not? No. Because see, there's a gap. And this point is down here. So I'm going to take what you just said. I'm going to write this more mathematically. Because really, I didn't do anything mathematical yet. Just basic stuff. And this says this. In order for a function to be continuous, I'm going to sum up everything you just wrote. It must satisfy these three criteria. All of them. If one of them does not work, the function is not continuous. The first criteria says this. 1. F of A is defined. 2. Lim x approaches A of f of x equals to L. So there's actually a limit. 3. Lim x approaches A of f of x equals to f of A. This sounds confusing, but I'm going to go through each of my 3 examples again. Now you're going to answer it with using math. Let's look at the first graph I give you. It's a very simple one. Okay. This one is not continuous because it violates one of these rules. Take it. Pragya, what did your neighbor say? It violates which rule? It violates rule 2? Why does it violate rule 2? First of all, okay, let's say this point is A, by the way. That point is A right there. So rule 2 says there's a limit. Is there a limit as you approach A for this graph? There is. So therefore, rule 2 is not violated. Which rule is violated? Chakshu, what did your neighbor say? Rule 1. See, rule 1 says f of A is defined. Problem is, f of A doesn't exist. There's no point here. So this one is no because it violates rule 1. Violates rule 1. That's the power of rule 1. Says, in order for you to be continuous, it has to be a smooth curve. But there's nothing here. So it violates rule 1. We also said this was a no. The question is, which rule does it violate? Okay, talk to your neighbor again. And I'm going to be asking you what your neighbor... Manat, what did your neighbor say? Which one does it violate? It violates rule number 3. See, this is rule 3 says there is a limit. Check. The limit's right here, L. But the limit is not the same as f of A because f of A is here. So I'm going to write down f of A. That's f of A. Okay? F of A exists, is right there. But the problem is no, because it violates rule 3. Violates rule 3. Now some of you say, Mr. Snow, how come you didn't give us an example for rule 2? Guys, come up with your own drawing. Here, I'm going to walk around and give you some time to play with this. I want you to create a graph that violates rule number 2 when x approaches A. So, have fun. I'm going to pause 2. So when I walked around, so let's say this is A right here. We're going to call it A. Rule 2 says there has to be limits. So all you have to do is draw a graph that does not have a limit. Okay? Maybe I have one here. Maybe it goes like this. Maybe I have one somewhere down here. And go something like that. Okay? There's no limit for this one. So there's an example of rule 2 violation.
There doesn't have to be 2 points, right?
No. But as long as you draw a graph without a limit, that's fine. That is an example of rule 2. So this is no because there is no limit. No limit. Interpol, question?
If it goes to like positive infinity and negative.
Then that's fine. Yeah. Okay. If one's positive infinity, one's negative infinity, then that works. So there's many, many different ways you can do this. Question, member?
There's just one positive infinity. Because infinity isn't really
Yeah, kind of weak answer. I'd rather you have this. Better. Okay. Part 2. I'm going to load up a graph. I'm going to give you some questions to answer in this graph. And this time, you can analyze it. All right. What I have here... guys, Karan, turn around. I have a graph. There are points of discontinuity. You're going to tell me where is it discontinuous and why. Where is it discontinuous? Oh, sorry. Discontinuous. And why? So tell me, which rule does it violate? It could be more than one. Could be all continuous. Or it could be just one answer. Write down. I'm going to walk around, share with your neighbors. Annika. Where's it? Give me 1 point where it's discontinuous and why. Here's my first point right here. F of 1 is not defined. Not defined. It violates rule 1. So that's my first one. Annika, choose the student for me. Go. Jasleen. Second point. And why? Why is 3 discontinuous? It violates rule 2. What does it mean by? Explain more in detail. There's no what? What does rule 2 say? There's no limit. See, there's no limit. No limit. Oh, I can't write today. No limit as x approaches 3. Okay. There's absolutely no limit. Jasleen, male student, go. Karnveer, what's another one?
5.
Why is it 5?
Rule 3.
Rule 3. See, a violation. It says the limit is not the same. Limit is not same as F5. Okay. That is the 3 golden rules for continuity. If any one of those is broken, your function is not. Okay? Because f of 5 is here. That's f of 5. My limit is here. That's L. They're not the same. I'm going to give you questions for you to practice. All right, I want to wrap this up with part 1 with something called, see, you can work when I give you a graph. What if I give you an equation? How to find points of discontinuity continuity from an equation. See, I give you a graph, most of you are pretty good with it. But now, what if I give you an equation? I'm not going to teach you too much. I want to see who can get the idea of this. X squared minus x minus 2 over x minus 2. I'm going to ask you, where is it discontinuous? So if I give you an equation, the question is, where is it discontinuous? Anyone have a guess? And why? Why and where? See, you don't have a graph anymore. You have an equation this time. Now, Karen, do you want to guess? Where is it? Why is it 2? See, everything, if I give you an equation, in order for it to be continuous, remember it has to be defined. So, discontinued points, continuity, points occur where x is undefined. X is undefined. By simple logic. Because rule 1 says you must have to exist. If I can find points where it doesn't exist or is undefined, so which really means is what I'm looking for is my domain. Domain means a set of all possible values. In this case, x cannot equal to one simple number. In all fractions, doesn't matter what you have, the denominator can never equal to 0. So in this case, the answer is x cannot equal to 2. So there's a point. So we can say this. It is discontinuous. Discontinuous at x equals to 2. That was easy. What if I give you this? F of x equals to 1 over x squared 1, and this is if x doesn't equal to 0, if x equals to 0. I'm going to pause it, let you have some. This is going to be 0. Question is, where is it discontinuous? Some of you can probably just look at it. Ruby, where is it discontinuous? At x equals to 0. Because here, when x equals to 0, it's undefined for that one piece of the equation. So it's discontinuous at x equals to 0. Easy. What if I give you something like this? And this is your SuperNote question for today. Good luck. Represent your team. I want, where is it discontinuous? F of x equals, and you got to say why. There's this fancy symbol that I taught you before. Oh, yeah. Where, in order for you to understand this, you need to know what this symbol represents. This symbol means an integer that's less than. So if I put in, guys, if I put in 2.99 in here, this would become 2, agree? If I put in 3, this would become, or 3.1, it would become 3. So problem with this is, which rule does it violate actually? Rule 2, sorry? 2, because there's no limit. Because if I go limit as x approaches, let's say, 1 of this, the answer is no, there's no limit. So in other words, which number, where is it discontinuous? It's discontinuous at every integer. Because at every integer is discontinuous. There's no limit. So the answer? At every integer. So, your work. Write this down, please. Grab your textbook. Page 112. Numero. 3 to 27 odd. You can't do any more than that. If you want to try the even one, try the even one. But the answer's on the website, not too trustworthy, but it helps you out. 112, 3 to 27 odd. And that ends your recording for today.